we're going to go ahead and get started, and we're going to work on some items that have to do with IP addressing. So what's an example? Let's give in your lab work, okay, in the computers you currently have, you have an IP address in the computer. So you have a router and you have a LAN, okay? So Tom, what's an address on your LAN? I forget what we used the other day. 172, 16,
15,
1. Okay, that's a workstation sitting on there. /24. So the 24, these are things, a little bit of review. 24 is prefix bits, right? How many bits are in each one of these numbers? 8. Okay, we talked a little bit about that the other day. So there's 8 bits that represent 172. And then there's 8 bits here, 8 bits here, and here. So 24 bits then are representing this part of the address, which is what part? What if we were going to put another computer on this network? So this is one of them that happens to be on this LAN. What if we're going to put another one on? What could we use for an address?
.2.
.2. You would change this here. This represents the network part of the address, and this represents the what we'll refer to as the host part of the address. And then the other day, we talked a little bit about each of these are 8 bits. So how many bits do we use in IP addressing? And today we're just talking about version 4.
32.
32 bits, thank you. Okay, so there's going to be 32 bits that represent the address. What did you use for this address right here for the router?
.254.
Okay, so 172, 16, 15, that means it's on the same network, 254. And the reason we know it's on the same network is because of the prefix bits. Now, what did you configure in the router? Instead of calling it prefix bits, what did you do? Subnet mask, right? 255, 255, 255, 0. Right? And the same subnet mask for both of these. 255 is how many bits? Anybody know? We haven't actually worked on that yet, but it's 8 bits. We have 8, 8, 8. That makes sense?
Yep.
That's why we say we have 24 prefix bits in an IP address. Then coming out of here, we went to a multi-layered switch. That went to another router. And that went to actually NIACC went to the IT department, which then eventually went out to the internet. Are we good? Not completing this part. Now, what we want to do is we want to understand more about IP version 4 addresses, okay? 32 bits. So what the router really sees, what's really looked at are the 32 bits and what's represented in those 32 bits. We talked about that a little bit the other day. So let's look at an example. Let's start out with, first of all, we're going to talk about number systems, just in general, just number systems. So you wouldn't necessarily need to write this down, but wherever and whenever we have a number system, a base 10, so we use 10 digits to represent that, and those digits are the digits 0 through 9, and so everything is base 10. 10 to the 0, anything to the 0 power is 1. You remember that from your trade class or whenever you took that. And then tens, hundreds, thousands, so we can make a number infinitely large and we can make a number infinitely small. 1 over 10 to the first would be tenths. 1 over 10 to the second would be hundredths. Okay? Now in computers, we can understand that as humans, right? We can have a number that looks like 1,028, 1 groups of 1,000, 0 groups of 100, 2 groups of 10, 8 groups of 1. 1,028. So computers just work with way back in time on and off circuits or core memory. Is electricity going this way or that way? Is it on or off? Anyway, they use base 2. They use the digits 0 and 1 to represent that. Either there's a mark or not. Base 2. So if we were to write out base 2, 2 to the 0, let's start there. 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, and 2 to the seventh. You know what I'm going to do? I'm going to rewrite those. I'll just do this. Myself a little room. One, 2, 3, 4, 5, 6, 7. So 2 to the 0 is 1. 2 to the first is 2. 2 to the second is participation.
4.
Thank you.
8. 16. 32. 64.
128. So let's practice something right now. Okay. If we did this the other day, what bits represent 172? Right here. Okay. Can you still see on the screen? Okay. Right here. I'll make it a little bit bigger. What bits would represent 172? 8 bits will represent 172. Will there be a 1 here or not?
Yeah.
What? Yes, there'll be a 1. That'd be a group of 128. So you can take 172 minus 128, and how much we have left over?
44.
Excuse me?
44.
44. I think we did this one the other day, didn't we?
Yeah, that's one.
Okay, so I'm going to go ahead and finish it. So do we have a group of 64 we can take out? No?
Yes. Yeah.
1. What is that, 32? Make sure you watch my math. Okay? 12. So can we take a group of 16?
No. Yes.
We can take a group of 8. A group of 4. 0, 0. You follow that? So these 8 bits really represent that number right there. Okay? What bits would represent 255? It'd be all ones. 255. So it'd be one group of 128, one group of 64. If you added them all up, you get 255 total. 256 options, because the other option would be all zeros. Okay? So that's how it works. So really, when we look at these addresses, the computer doesn't really see 172.16.15.1. Okay? It really just sees the ones and zeros, one big group. It doesn't have dots in there dividing them up into groups of 8. Okay? We like to do that because it's easier to see. So as humans decided to do it this way, this is what the computer says. So what we should be able to do is convert back and forth between the different numbers. So if I was to put an example up here, I'll put it up here in blue. So if I had 0, 0, 1, 1, 0, 1, 1, 0, we should be able to figure out what that is base 10. Okay, so we got one group of 32, one group of 16, one group of 4, and one group of 2. 10, 14, 54. Did I do it right? You guys follow? So 54. Now, some of you, base 10. This whole number, base 2. Now, you can use a calculator to do this. You can use a calculator to do this. But somewhere along the line, you've got to be able to visualize this and be able to work with these by hand. At least the simple end of it. Okay? The simple part of it. So, you just worked on Wireshark. Did you have it show the information? Was it showing all ones and zeros down below?
Yeah, it's down below.
Yeah, so you're looking at the ones and zeros. So now you could, if you could start counting and figuring out where's what. For example, when it did an ARP for the MAC address, would you see all ones when it did the initial ARP for the destination because it sent out a broadcast, right? So we're good, right? We're good with those terms. Should I repeat them up here? We either send a unicast between 2 locations. We can send a broadcast. That means we're going 1 to all locations, or we can send a multicast. Multicast. Okay? We can send a multicast, and that's going to just the ones it needs to go to. Okay? Multicast. That make sense? They divided IP addressing, and you can look at the curriculum. I'm not going to go through the whole thing. But if there's, in the addressing, if there is a 0 at the very beginning, then that would be what class of address? We went through this the other day briefly. Maybe not. If there's a 0 at the beginning, it's a class A. If there's a 1 and a 0, that'd be a class B. If there's a 1, 1 and a 0, Class C, there's a 1, 1, 1, and a 0. Class D, and we're not going to worry about the other ones right now. So think about this for a second. What range of IPs could you have if there's a 0 in the very first bit?
Not very big. Zero to 127.
Right. You couldn't. This would be 128, so it's 0 up through 127. 127, 255, 255, 255. And 127, there's a group of them reserved, for certain things, like loopback. Okay, if you pinged 127.001 in your computer, it's going to check your NIC card, see if it's working correctly. You have a loopback. So some are reserved for different things, and we'll learn as that goes on. So this is Class A. Okay, so we have that range from 0 in the first octet, I can just write it out, to 127.255.255.255. Okay? Squeeze it on. So then the B must start at what? At 128, but it can't go over what? What's this one? What's a C address? Well, there's 2 1s there. So the C starts at what?
192.
192? And the D starts at 224. In a lot of cases, Class D, there are cases where it's used for like multicasting. And then the other classes, there's certain parts of them are private addresses, right? You've seen some private addresses like 192.168. Just used as private addresses. The other ones can be used as public addresses out on the internet. Questions? Do you have access to your router?
Yeah.
Or else, let me bring up a couple examples up here.
So the 10 whatever is that, that's a Class A or is it just private?
10, it's Class A, but it's a private Class A address. The whole 10 range. It can't be used out in the public domain, the internet.
I think we use almost any address as a private address, or is it only 10 and 172?
The private addresses,
Yeah.
we can use any of the private addresses internally that you want to in a network. Does that make sense? Some more questions.
Right, confused.
What's that?
I was thinking like if you could use any, but if you use any, you're wouldn't that confuse your DNS? Like I was thinking if you use like a 206 or whatever for private address, but then you'd be confusing with.
You don't. People do that. I've seen that done where people accidentally use public addresses internally. They just made them up. You shouldn't do that. That's
Because that would,
if they'd ever leak out to the internet, that would not be good. Even though your ISP would never let them leak out.
you wouldn't be able to access that site because it think it was your own internal one, wouldn't it? Or was it just
No, you could configure an internal network with any addressing you want and make it work. But if you use public addresses, then you would never want that internal network to communicate with a public network on the internet. All right. So let's, I'm going to share this screen briefly. So if we were to look at, you guys see that up there, okay? Yeah. We could turn down the light. If I do a show IP route, right, this is connected, this is that multi-layered switch that's connected to all of your guys's internal networks, okay? So for example, right here, this is Tom's computer, right? Yeah. Okay, that's his, it's not his specific computer, it's the network that his computer's on. Does everybody agree? It's this address, okay? And this is where I'm going to send a packet out if it needs to find that. Okay, so let's just do this and kind of think about what I'm doing. I'm going to do a ping. Well, first, I'll do an ARP -A. Oh, my bad. I don't want to do an ARP there. Let me just go ahead and ping. We won't. I need to open up a command prompt if I was going to do an ARP. I'm just going to do a ping 172.16.15, right? 1. Did you have connectivity out?
Yeah.
Did you turn off the? Yeah. So Tom has some virus software running on his PC. It lets him do work out, but won't let me in. So he has to adjust some firewall stuff. And there. Okay. So let's just look at. Okay, I sent a message to that computer and it sent it back. So when it looks in the routing table, these are all, this is classful, right? These are all 192s. So if it's going to match with one of those 192s, how many bits does it really have to look at? The first two? Get it? So when it hits a 172, it doesn't have to, it can figure out which class, okay, right away. All these directly connected. Because this 172, right, they're going to start with, they'll always start with, right, a 1 and a 0. This will always be a 1 and a 1. Okay, so the router can come down, finds this match right away, comes in, then it can go ahead, go further in and find a match and sends the packet out this port. That make sense? What should we be able to do? You should be able to take the 1s and 0s and convert those into a base 10 number for IP address. Okay? You should be able to understand that based on the prefix or the subnet mask, you should know what part of an address is the network part and what part is the host part. Okay? So where does it, when the traffic, okay, I sent a ping from here. We have multiple people connected here. Okay, so this router sent it to this router based on the IP address. Then it got into this router and it sent it out to the workstation. Then the workstation responded, right? How did this router know where to send it? here. IP address, right? And then what did it put on it when it left here? The MAC address, right? So if we had multiple computers on here, how many computers could we put on here? Let me help you with that. If you did math, this many bits would give you 256 combinations. For a host, okay, a host, what usually we think of as a PC, we never assign the host 0, okay, and we never assign the host 255. This represents the network, and this represents a broadcast. So, what does that leave? 254, 256 combinations. So we have 254.
And then you have to have one device pointing internally for them to talk on.
Right. So we have to save a number for the router, right?
Yep.
So we actually end up with 253 hosts we can put on the net. We start with 1 and go up. That makes sense? So you have the top and the bottom range of what hosts you can put on the net. Any questions? All right.